The battlefield is evolving, and the U.S. military is leading the charge with a fully robotic army. Imagine machines outthinking, outmaneuvering, and outperforming humans in war zones. The future of warfare is here. Before we get started, I want to tell you about the AI with Win merch we've designed just for tech enthusiasts like you. From AI themed t shirts to must have accessories like phone cases, wireless chargers, and laptop sleeves, our collection brings the spirit of AI and EV innovation to your everyday life. Check it out at the link in the description or go to aiwithwin.com. Now, back to the video. The Bear robot was developed by the American company VCNA Technologies to rescue soldiers injured in combat zones. However, its applications extend beyond military purposes. This versatile robot can lift and carry loads of up to 270 kilograms, 600 pounds, over long distances, thanks to its high powered hydraulic drives. Its exceptional mobility is supported by two pairs of tracks, enabling it to overcome a variety of obstacles with ease. Early versions of the BEAR robot were remotely controlled by a human operator who relied on the robot's sensors, cameras, and microphones to navigate and perform tasks. As its artificial intelligence capabilities evolved, the robot gained the ability to process higher level commands, such as go to this location or pick up that box. If the robot encounters difficulties, it requests operator assistance to complete the task. The latest Bear model is equipped with infrared night vision, optical cameras, and advanced microphones, enhancing its functionality in challenging environments. Meanwhile, the Vision 60 UGV, unmanned ground vehicle by Ghost Robotics, is a highly durable, mid-sized, four-legged robot designed for defense, homeland security, and enterprise applications. It features an agile and weather-resistant design, making it adaptable to various environments. The V60 can operate in blind mode, allowing it to maneuver without relying on visual input, thanks to its robust control core. Weighing 51 kilograms, 112 pounds, the Vision 60 can carry payloads of up to 10 kilograms, 22 pounds. Its modular design enables quick assembly or disassembly within 15 minutes, and its legs and arms can be swapped as needed. Controlled by an operator using a controller similar to a gaming pad, the robot can walk at speeds of up to 3 meters per second, 6.7 miles per hour, and operate for 3 hours or cover 10 kilometers, 6.2 miles, on a single charge. The Vision 60 also offers 360-degree situational awareness with cameras on its front, rear, and sides, making it ideal for effective planning and real-time adaptability in diverse scenarios. The U.S. Army Research Laboratory has teamed up with Army engineers and multiple industrial enterprises to develop a line of autonomous mini robots. These robots are designed for operations in challenging environments such as urban areas, mountains, and caves. One notable innovation is the autonomous reconnaissance spider robot, a compact scout equipped with advanced sensors for navigation and obstacle avoidance, along with standard and thermal cameras. These robotic reconnaissance platforms will allow for information gathering in environments that are too dangerous for humans. As flying and walking drones become increasingly common, these next generation robots are pushing the boundaries of military technology. The United States Marine Corps is currently developing a versatile drone capable of operating on both water and rough terrain. Known as GuardBot, this unique robotic system is designed for extensive surveillance and the detection of improvised explosive devices, IEDs. Its sealed spherical construction houses observation cameras and sensors, making it an ideal platform for covert operations. Last year, the GuardBot underwent extensive testing, successfully navigating both water and land. It was deployed into a body of water, executed pre-programmed movements on both surfaces, and then returned. The drone achieves a speed of approximately 6.5 kilometers per hour on water and up to 35 kilometers per hour on land, handling a surface incline of up to 30 degrees. Inside, the GuardBot is equipped with stabilization mechanisms and a movement system that shifts its center of gravity forward and backward, propelling it in the desired direction. The spherical drone is powered by reliable Eagle Patcher batteries, allowing it to operate for up to 18 hours without needing a recharge. GuardBot can function in two modes: remote control, where it is directed by an operator, and autonomous, where it silently awaits commands to perform tasks. As a mobile sensory platform, GuardBot excels at covert surveillance. enabling remote inspection and identification of various objects, including chemical substances. With its onboard laser, it can also detect explosives and transport bombs, making it a valuable tool for bomb disposal units. American company Saros Robotics has introduced its impressive exoskeleton, the Guardian XO, designed to make heavy lifting effortless. The exoskeleton allows the operator to carry loads up to 90 kilograms, but with the sensation of carrying only 5 kilograms. This groundbreaking technology has caught the attention of the U.S. military, as it could significantly improve soldiers' performance on the battlefield. The Saros Guardian XO is a robotic exoskeleton with 24 degrees of freedom, enabling a walking speed of up to 1.3 meters per second. It comes with a battery that lasts approximately 2 hours, and when depleted, it can be quickly replaced. According to the manufacturer, the exoskeleton is easy to put on and activate, taking just seconds, while users can master its use in only a few minutes. Unlike traditional exoskeletons, the Guardian XO operates with a real person as its control system. In essence, it's not the operator carrying the exoskeleton, it's the exoskeleton that carries the operator. Despite its bulk and a weight of about 70 kilograms, the user hardly feels the weight of the robot or the load being carried. In a related development, Boston Dynamics has created BigDog, a quadruped robot with its own impressive capabilities. This robot represents a cutting edge advancement in robotics, designed for load bearing and navigating rugged, uneven terrain. One of its standout features is its remarkable ability to maintain stability while moving, thanks to dynamic stabilization technology. With an impressive payload capacity, this robot is highly valuable for transporting equipment and materials in hard to reach locations. Equipped with powerful and flexible legs, it can easily overcome obstacles like rocks or snow. The robot is capable of moving at significant speeds and is outfitted with an array of sensors and cameras for environmental awareness. Big Dog features around 50 sensors that monitor body posture, acceleration, joint forces, engine speed, temperature, and hydraulic pressure within the robot's engine. Both low level controls, such as joint position and force, and high level controls, like velocity and altitude during movement, are managed by the onboard computer. This system ensures precise coordination and adaptability across challenging environments. Megabots, a robotics company, has developed the massive combat robot Eagle Prime, designed to represent the United States in duels with similar machines. Initially created as an entertainment project, Eagle Prime has attracted the attention of the U.S. military, which sees potential for such advanced robots to be integrated into the Army in the future. This 12-ton behemoth stands at a towering 5 meters tall and is mounted on a tracked platform for mobility. Powered by a 6.2-liter V8LS 3 gasoline engine delivering 430 horsepower, Eagle Prime is equipped with both a cannon and a claw. The robot is operated by two controllers, who showcased its capabilities on a small obstacle course. The total cost of the project was $2.3 million. The U.S. Army has acquired 350 new FLIR Cobra robotic systems through the CRSH program at a total cost of $110 million. Developed by Endeavor Robotics, the FLIR Cobra is a versatile, remotely operated tracked platform weighing 166.25 kilograms. With a maximum speed of 8 miles per hour and a runtime of up to 10 hours, this robot is equipped with multiple high-definition cameras, a 60-kilogram manipulator, and a remote control system designed for enhanced cybersecurity and interference protection. The FLIR Cobra is designed for a variety of missions, including explosive detection, explosive ordnance disposal, EOD, bomb disposal, persistent observation, and checkpoint or vehicle inspections. It can also be used to detect and identify chemical, biological, radiological, and nuclear (CBRN) materials from a safe distance. One of the most notable advancements in military robotics is the American remotely controlled T360 M2 MUT, a versatile hybrid drive tactical vehicle. This robot comes in two versions, wheeled and tracked. After a series of successful tests, it was officially adopted by the United States Marine Corps. The T360 M2 MUT is highly adaptable, capable of being equipped with various weapons, including machine guns or a 60mm mortar. It also has an unarmed transport version, designed for carrying equipment, evacuating wounded soldiers from the battlefield, conducting reconnaissance, or deploying drones. With a payload capacity of 433 kilograms, the robot can operate autonomously for up to 72 hours, covering distances of over 100 kilometers during that time. The future is already unfolding before us, but how we choose to wield this power could define the course of humanity's future. It's up to us, together, to shape how technology serves us, not the other way around. I want to hear your thoughts. Do you believe a robotic army is the future, or are the risks too great? Drop a comment below, and let's keep this conversation going.